Hey guys, welcome back to my channel. Today we are going to see how to calculate the pH value for weak acid versus strong base and also for weak base versus strong acid. We have already done one video on strong acid and strong base. If you haven't seen that, you can find the link of that video in the description box of this video. So we'll be solving the problems to understand it, and we'll see some easy tricks to solve such kind of problems. So if you have already gone through with acid base titration, especially MSc students, you can go for this video. So for this, first you should know the list of formula which are there, and this is the trick and easiest way to solve the titration of weak acid versus strong base problems. So as you can see here, weak acid, we know all weak acid having like acetic acid is a weak acid, and if you titrate it with sodium hydroxide, which is a strong base, so four stages are there for any titration. One is at starting. Okay, so at starting, what is present, the fraction will be 0. Then comes before the equivalence point, when you started adding some amount of base, you start your titration. Then the fourth stage is at equivalence point, where the acid is completely neutralized by base at equivalence point, and then even after that, if you start adding the base, that is the after equivalence point. So we have four stages and four formulas to solve the problem. And what will be present if the you haven't started adding the base, so you have totally present the acid, so that you can put this formula H plus is equal to under Ka, which is the dissociation constant of acid into concentration of acid. And then before equivalence point, you establish a buffer system between the acid and salt is formed, and you can use this equation, pH is equal to pKa plus log Ca minus, which is the concentration of salt divided by the concentration of the acid. This equation is called Hazel-Welch equation, and you can calculate the pH value for any buffer system for weak acid by using this equation. Then comes at equivalence point, where your acid is completely converted to salt. So you have here present in the system salt, and since the salt is slightly alkaline, so you can calculate OH minus concentration by putting this formula under root Kw over Ka into Ca minus. Kw is the ionic product constant, and we know the relationship Kw is equal to Ka into Kb. So basically for Kb, we are putting here Kw over Ka. Then after equivalence point, even if you add, you have the OH minus ions, that is base in excess, and we will calculate the OH minus ion concentration which you have added, and then we will calculate the pH. So this is the list of formula. Now we'll see how to apply it. We'll see very first problem where you have to calculate the pH for 0.20 molar solution of acetic acid. Okay, so we know acetic acid is a weak acid, and they have given only the acid, means they haven't started the titration yet. So this is basically they are asking the pH to you to calculate at a start, and you can then calculate directly by putting this formula H plus is equal to under Ka, concentration of acid. Ka is given to you for acetic acid, and concentration is also given. You can find the H plus, and then you know the relationship between pH and H. pH is equal to minus logarithm of H plus, and then you can find the pH value 2.7, which comes for acidic medium. So the problem becomes very easy once you finalize the stage of the titration. This is the second problem. For a weak acid, they have given Ka, which is titrated with respect to strong base NaOH. The concentration of the salt at equivalence point is given 0.01 molar. What is the pH at the equivalence point? So they have here mentioned directly that at equivalence point they are asking you to calculate the pH value. Okay, so we know for weak acid, the formula at equivalence point is equal to, which is slightly alkaline, and OH minus is equal to under root Kw over Ka, concentration of A minus. Kw we know 1 into 10 to the power minus 14, Okay, so and these are certain steps which I have explained here, how we derive this formula. Okay, so like we know it is the salt which will be present there, and for that we can calculate Kb, the concentration of the product divided by the concentration of reactant, and Kb is equal to Kw is equal to Ka into Kb. And at equivalence point we will assume the concentration of the both species are equal, so you can write 2H minus for both, and then finally you got this formula. Okay, so you put the values for Kw, Ka is given, concentration is also given at equivalence point. You got here OH minus concentration. Okay, so this is the key point which you have to remind yourself, that you have calculated OH minus, not the H plus. So once you calculate OH minus, you can find out the POH value, and then you can find out the pH value by using by subtracting it with 14. Okay, so pH is equal to 14 minus POH, and you got the value at 8. Okay, so this is how you can solve the pH at equivalence point. The next problem, where the pH they are asking to calculate for 2 molar solution of nitrous acid. Okay, so you should know nitrous acid is again a weak acid. So this problem belongs to weak acid category. Ka is given to you. So here again they are starting at start, no base is mentioned here. So you can I'll tell you the two methods here. One we have already seen by using the formula straightforward. The other is you can solve this equation. Okay, HNO2 if you dissociate into H plus NO2 minus. So you can write down the concentration in the square bracket. There are three stages. Initially the concentration of HNO2 is 2, and then that time H plus and NO2 is 0. What is the change here? Some change occurs here in the concentration, so minus X, and here it is going to form H plus and NO2 minus, so plus X. X is the new concentration. And at equivalence point you can write 2 minus X, and here the concentration of the species will be XX. And we know how to write the dissociation constant equation. K is equal to the concentration of the product divided by the concentration of the reactant, and so you can put the value x square. 2 minus x we can write, since x is going to be very small, we can write it approximately 2, and you can solve for x, which is the concentration for H plus. So you got the H plus concentration, you can put it into the formula and find out the pH value 1.52. This is a lengthy way to solve this problem, including all steps. At the same time, you can use the trick which I have given you by putting this formula straightforward, and you will get directly in one step H plus concentration and pH value. So as you can compare the two methods, this is very short method which gives you very fast pH value. In this problem, they are asking the pH for the buffer solution. Okay, and we know the Henderson-Hasselbalch equation we can use for buffer solution, where 0.03 molar ammonia and 0.05 molar ammonium ion is given. So base is given and its salt is given along with the Ka value. Okay, so for weak acid you can write this equation, and we know the Henderson-Hasselbalch equation, pH is equal to pK plus log salt, concentration of the salt divided by the acid. Okay, so here you can put the values here. We know pKa is again the same relationship, minus log Ka, so you can calculate the pKa here, which comes 9.25, and finally you can put the values for the salt and its acid here. Okay, 0.05, and you can find the pH value straightforward by using this equation. Then comes next problem, where 100 ml of 1 molar sodium chlorate with 1 molar of HCl. Okay, so HCl is a strong acid and sodium chlorate is a weak base. So this particular problem belongs to the weak base versus a strong acid. They are asking what is the pH after you add 50 ml of acid. So at particular 50 ml they are asking. We know the molarity of the two base and salt is same. So the equivalence point for the above reaction will come at 100 ml only. Since they are asking at 50 ml, so we will get the midpoint. Okay. So at midpoint, we should know the formula. And this is the first step. You can find out first how much volume of the acid will be required to get the equivalence point. So that is 100 ml. Okay, just now I told you 100 ml. Now for 50 ml you will get the midpoint. And this is the trick, another trick, that at midpoint, whenever they ask for midpoint, pH is always going to be equal to the pKa value. Okay, so basically whatever is pKa value, or here it is in this case Kb, so you can write and solve for this, and you can see that you are having the same answer here. Otherwise you can solve it, you can verify. Here the equation for weak base will be pKw minus pKb, okay, which is equal to actually pKa plus log Cb over Cbh plus. So concentration of the base divided by its salt. Okay, so now how to find out the concentration of the two species? We have this another trick or another formula. Concentration of the base will be MbVb minus MaVa divided by Va plus Vb, because we have excess of base before equivalence point. Therefore we have to write first base moles minus moles of acid divided by the total volume. So the data is given to you here. You are getting 0.33 molar. If you solve for the salt of it, then it is acidic, right? It is acid here. So you can find MaVa divided by Va plus Vb. And again you are getting the same answer, 0.33. And we know the pKb you can calculate by using this formula, and 6.44. So you can put here pH is equal to pKw minus pKb, plus you can see that you are going to cancel these two terms, and so the pH value is 7.56. Okay, so pH value is equal to pKa value. pKb you have calculated. You can subtract this minus 14. Okay, 14 minus this pKb, you will get the pKa value. So straightforward also you can solve this problem. Since you know it is the midpoint, directly you can put the pKa value after solving the pKb, and instead of solving all the steps. Okay, so very quickly you can do it if you know the chemistry behind it. So that's it for today. I hope you understood how to solve very fast, quickly all the problems related to weak acid versus strong base, or weak base versus strong acid. All the best. See you in the next video. Bye.